We were discussing that this is lecture number 0 of your advanced econometrics. It's about the basic introduction. We will be trying to recap the basics of some of your econometrics, and we shall be trying to see like how econometrics approach different problems and what exactly they are, what they mean by econometrics at the first place. And in this particular lecture, we shall be talking about the basics of econometrics and the basics of econometric modeling. The models, as we discussed in the previous session, that models basically explain the behaviors of individuals, their behaviors of different economic behaviors. Like, say, for example, the economic models explain economic behaviors. Political science models explain the different behaviors of the different polities. Similarly, the psychological models basically explain the different models related to the psychology, or and this is something like, they are basically, like they're the different models. The economic model explains the economic phenomena that happen around us, like, say, for example, consumption, income, demand, supply, and that all right. So we will be discussing some basics of it. Now, if you look at the data description versus modeling, when you provide the data description means you provide the information about the data. You provide what exactly the data telling you. The data description show you how the variables are correlated, how one variable changes when some other variable changes. All economic relationships, if you see closely, you would find out they all are somehow related to each other. Whatever is happening in your economy, this is happening because of some other variable. Like, say, for example, why inflation in your country is increasing. The answer to this question lies in the behavior of some other variable. Similarly, why unemployment is changing or rising or falling in your country, that is again, like, can be understood by looking at some other variable. Similarly, like the way you consume in your household, that depends on your income. The way you demand the goods, that depends on the prices. So that basically is a correlation. So a lot of variables are interrelated to each other. When you try to change one variable, it brings change into so many other variables that are connected to that variable somehow or the other. Like, some of the variables are correlated directly, or they are actually directly related to each other, and some of the variables are indirectly related to each other. So when you try to find out, or when you try to describe your data sets, you generally try to find out that which variable is correlated with which variable, and how one variable changes when some other variable changes. That is absolutely necessary, because if you really want to bring change into the economic behavior of a country, or economic behavior of an individual, or economic behavior of a firm or industry or whatever, you have to know, like, which variable you have to change to bring the change into that variable. Further, the data descriptions provide the strength of these correlations, like how strong this correlation is. When one variable changes, so many other variables changes, but some of the variables, the change in some of the variable is small, and change in the sum of the variables actually come when it's very large. So when you see, like, say, for example, when you try to deal with the problem of inflation in Pakistan right now, as we discussed, or as you already know, that the SPI, the sensitive price index in Pakistan for the last week was 44.5%. So the prices on average of the sensitive commodities has risen by 44%. So it's a very big number that basically Pakistan is dealing with, and that is going to be worse in the upcoming days, because of the floods and because of the shortage of supplies, because of the these all floods and disasters. So how can you deal with this problem? If you really want to change or reduce the inflation, you will have to do something. And what is that thing? You will have to find out with which variable this particular variable is related so strongly. So it cannot make statements about the causal effects. The causal effects cannot be found out through data descriptions. By the causal effects means, say, for example, you must have learned about the cause and effect relationship, like what causes this and what causes that. Like, there are so many correlations exist. Like, say, for example, when you find out the correlation, you find out that this variable is happening. And when you look at the correlation between the two variables, it says to you that this variable is happening because this variable is also happening, and they are happening at the same time. But it does not mean that one variable is causing the other. The cause and effect relationship can be like, say for example, one variable that is changing because, and the two variables are changing at the same time, they might be changing because of some third variable, or they might be changing because of some other kind of a situation. So the data description, what the data description does not provide you, it does not actually give you the causal effects between the variables. On the other hand, the modeling, it allows you to test theoretical relationships. When you make a model of demand, you can test the relationship between price and quantity demand explained by Marshall. When you look at the model of consumption model, you can test the relationship that was explained by Keynes between consumption and income. And similarly, like through the modeling, you can also estimate magnitudes. By the magnitudes, again, we mean like, how much change in consumption comes when your income increases or decreases by $1, say, for example, all right? And similarly, like the modeling can also help you identify the causal relationship. The causal relationship means, again, the cause and effect relationship. Some of the variables are changing, like, say, for example, my age and your age is actually increasing at the same time. Now, if somehow we try to find out the correlation between your age and my age, that will come a positive relationship. That will come as a positive relationship. But when can this, like, is my age, increase in age is causing the increase in your age? The answer is no. We are actually growing up old at the same time. We are actually growing up older at the same time, but that actually is happening just because it is happening. It's not because it's not happening like your age is not increasing because my age is increasing, or my age is not increasing because your age is increasing. Are both like both of us basically are having we are actually growing older, but like that is happening at the same time. And there are a lot of things basically that are happening at the same time. Like, say for example, my consumption is increasing, so as your consumption is increasing, but it does not mean that my consumption is causing your consumption or your consumption is causing my consumption. That is something we cannot find out from the data description, but the modeling allows us to find out that what kind of a causal relationship exists between one and two or three or four variables. That's what basically is very important part of the modeling. These modelings help us find out that what kind of causal relationship exists between variable X and variable Y, variable X and variable Z, variable W and the variable X or XY. All right. So you should be knowing this. Now look at this, a very, very simple model. Now, do you think the migration is good or bad? Like, say, for example, right now, it's about immigration anyway. But say, for example, I just change this model according to the current situation. If you look at this, basically, like the attitude towards migration. Attitude towards migration means like recently what is happening, that there are so many people who are actually getting affected by the floods are moving to Karachi. Now, what is your view about it? Like, how do you make those views? Those views are made generally by the newspaper readership. The people who basically read newspapers, they have got their views about the immigration or immigration. Say, for example, like this model was actually made when there was a hype in the US about the people traveling to the US for the immigrations, and Donald Trump was in the power and he was trying to stop people to come and just just have immigration applied like at the US. At that point of time, the study was conducted that what actually makes people believe that the immigration is good or bad. And similarly, like say, for example, what do you think about the migration, internal migration that is going to take place? Is it good or bad? That will be depending on that how much knowledge you have got from the newspapers, or how much other factors are affecting. So the attitude towards the migration is being affected by majorly on the newspaper readership. The more you read the news, the more you watch the news, the higher is the likelihood that you develop some kind of attitudes towards the immigration or migration. You just basically feel that right or wrong. That's what basically is the idea here. So this is what basically the modeling does. The key issues here are sampling. When you make a model or you try to test a model, the very first problem that you encounter is the sample. Like say, for example, when you again go to the doctor, the doctor suspects that you have a malaria, or you have got some other kind of disease, or say for example you have got a problem of you actually have become diabetic, say for example. And what does the doctor ask you? He asks you to go and get yourself tested for this. All right. Now when you go to the lab, what does the lab person do? He actually takes a sample from your body, and that sample actually explains some kind of presence or absence of some kind of elements in your blood or in the other parts of your body. And that actually tells you that that whether there is a chance of having this kind of a disease or not, and if you are having that disease, how severe that disease is. All right. So so the first issue that you face in modeling and testing your theoretical models is the problem of sampling. Which sample you should choose? Which sample you should be looking into? Which sample you should be considering, or which sample you should be taking? Because the sample actually plays the key important role, specifically in research. Like say for example, if I want to know the reading habits of the students, and if I choose a sample for that, and if I choose wrongly all those people who study or read quite a lot or quite less, they are very much of a kind of a same group. So my results will be biased, my results will not be good, my results will not be representative of the whole data sets. All right. So the sampling is one of the very important problem. Another problem that comes is the measurement errors. What happens is, like say for example, when you say that keeping other factors constant, if price of any commodity increases, its quantity demand decreases. All right. And you actually make this kind of a model. Say for example here, you say that QD is equal to 10 minus 2p. Now if you look at that, if you think that p is 2, what will be the QD?
6.
QD will be 6. All right. And this is what your model tells you about. All right. This is what actually your model tells you about. That the model tells you that if you set price equal to 2, your quantity demand actually is 8. But do you really get 8 as a quantity demand when you really look at the real data sets? When you look at the data sets which basically are available, or when you just look at the real kind of happenings, generally you find a difference between what you actually estimate and what actually the value of the quantity demand is. So there are a lot of things basically that happens, and that basically also happens because of this omitted influences. What happens that when you make a model, say for example here, what are we doing basically? We are just relating the quantity demand with price. Along with the price, there are so many other factors that are affecting this quantity demand as well. Say for example, your income, your taste, your fashion, your weather, your family size, your religion, your social values. There are a lot of things that are determining the demand curve or the demand value, but you are just taking the price. So there are some kind of omitted influences. There are some kind of influences. There are some kind of variables that should have been there into the model but have not been included into the model. All right. And that's what basically happens, and these are the problems that basically you have to face. So omitted influences basically are dealt with. So for that, you have to have a correctly specified model. And by the correctly specified model, we mean like a model that actually should include all those variables that should be there, and they should not include all those variables which should not be there. Similarly, another issue that happens is the simultaneous causation. At the same time, there are so many things that are happening because one thing is causing the other, and the other thing is causing something else. So you have to take care of that as well. What basically are the problems, and what kind of simultaneous causations exist there, and how can you deal with those all problems. Now look at this. The simultaneous causation could be, or the simultaneously, basically one thing is causing the other thing is causing the first thing. Say for example, that when you read newspapers, you make your mind about the migration or immigration. But like towards your, like say for example, your attitudes towards migration can also force you to read newspaper. So the newspaper reading can cause, say for example, sorry, newspaper reading can cause or change your attitude towards migration, but at the same time, the attitude towards migration can also change your newspaper readership. Like say, for example, you are reading newspaper because you have got some kind of attitude towards migration and you want to read through the newspaper that what are the impacts of migration taking place, how many people are migrating to your city, what is happening and what is not happening, all right? And similarly, the other factors, and these other factors basically have got the influence. So that influence can also be like, say, for example, the other factors are basically affecting the attitudes towards the immigration. But, like they can also be affecting the, like newspaper readership. So simultaneous causation is an issue that you have to deal with when you are making a model or something like, and you're actually improving that. The solutions is, like what you can do about it. A better data can help to deal with the problems due to sampling, measurement error, and observed omitted influences. If you are able to collect good data sets, better data sets, or the data sets that basically represent the true problem in the variables or true problem in the population. So the methods that we are going to study will help us combine data, economic theory, and statistical methods to help address these problems. This is what econometrics is all about. So it is possible to deal with simultaneous causation and unobservable omitted influences. And that's what basically we are going to learn, how you can do it, how can you basically combine economic theory, statistical method, and mathematical problems to actually solve these kind of problems and study the behaviors which are particularly related to economics, all right? So economic behaviors are studied through the linkage or amalgamations of the statistics, mathematics, and econometrics, and that basically help you understand what exactly is happening. Suppose like, the topics that it's not we will use, it's something that we use generally. Like say, for example, you might find out the relationship between education and wages. You know that like, your wage that you get depends on your education, all right? So you can actually link up the wage and education, but along with that, like, the wages affect the education and education affects the wages sometimes, because like, if you are earning more wages, that can perhaps help you actually get more education, say for example. But here we are not actually discussing this simultaneous causation here. So consumer demand, what factors this consumer demand depends on? It depends on the price, it depends on the income, it depends on the taste, it depends on fashion, it depends on weather, it depends on religion, it depends on social values, it depends on like, literally on everything. Like say, for example, right now in Karachi, the demand for all the goods and services and housing and everything is going to go up because of the migration of so many internal migration of so many people from Balochistan, from Sindh, and from other regions, all right? So that's what basically is going to happen now, and demand is basically rising because the internal migration is taking place in Karachi or Lahore or like, other parts of the urban centers of Pakistan. So the consumer demand is going up because internally people are migrating. It's not because of the income, it's not because of the taste, it's not because of the fashion, it's just because of the more people actually actually coming to your city, all right? And similarly, the labor supply depends on wages again. And you have learned about that. The labor supply curve is a backward bending curve. Up to certain point, your wages actually take you to more labor. But after some time, when your wages increases from certain amount, you basically start giving like supplying less labor. So the labor supply behaviors can be illustrated, and there are a lot of things basically that you can study. Theory. What factors does theory predict have an impact? What factors can we exclude? What is the nature of relationship we expect? When you like what happens in econometric modeling here we have is we do not take into account the theoretical underpinnings of those relationships. First of all, whenever you are actually empirically running your model, when you are actually by empirical model, we mean the models that are based on data sets. Like what did Marshall do? Marshall explained the relationship between price and quantity demand But here, so many people, what they do basically, they take the data about the quantity demand and they take the data about the price and they try to find out that what kind of relationship exists between price and quantity demand. For some of the goods, this relationship is strong. For some of the goods, this relationship is very strong. For some of the goods, basically, this is elastic. For some of the goods, it is inelastic. All right. So what factors does theory have an impact? What factors theory explains? Like whenever you make an econometric model, you have to always be careful what theory says about this. Theoretical foundations are the most important factors that basically you have to look into if you really want to, study some kind of a relationships. Empirical relationship depends on theoretical foundation. So what theory explains, what theory predicts, that what actually has got an impact. What factors can we exclude? Like there are, all the factors cannot be included into the model. Like say, for example, when you make a model, if the model basically, if you think, like say, for example, if I ask you again that on what factors your quantity demand depends on, you will be counting many variables. Tens of variables can be counted as important variables that might affect your quantity demand. But can you include all of them? Can you include all of those variables?
No, sir.
Obviously not. Why not? Because again, you cannot do that, because that actually will cause a lot of problems in your econometric model, and you will not be having any kind of results when you have got so many hundreds of variables actually present in your model. Similarly, what is the nature of the relationship we expect? It is very important that we know, what kind of relationship we are going to have when we are going to run it. Like say, for example, before running the model, we always actually have got an expectations of sign. Like say, for example, if you're running a relationship between price and quantity demand, what sign you expect of your independent variable, I'm sorry?
negative.
Negative. This is what basically you actually expects this relation to be negatively relative relationship, because that will actually, that's what basically the theory says.